The mission would use a Falcon Heavy rocket to launch an Io flyby spacecraft, which would consist of a modified Orion capsule and a habitat module derived from the Bigelow Expandable Activity Module, BEAM. The habitat module would serve as the living quarters and the scientific laboratory for the 4 astronauts during the long-duration flight. It would also carry an Io surface probe, ISP, which would be deployed before the closest approach to Io. The launch date would be June 15, 2025, and the flight duration would be about 2 years. The spacecraft would use a gravity assist maneuver around Mars to boost its speed and trajectory towards Jupiter. The closest approach to Io would be on April 10, 2026, at an altitude of about 500 kilometers above the surface. The astronauts would observe the Moon and its volcanism using various instruments, and communicate with the ISP, which would land on a relatively flat and stable region near the equator and transmit data back to the spacecraft. The ISP would measure the temperature, pressure, composition, and seismic activity of Io's surface, as well as look for signs of sulfur plumes, lava flows, and possible extremophiles. The ISP would also carry a small camera to capture images of the terrain and the volcanoes. The return to Earth would be on August 20, 2027, after a total of 797 days in space. The Orion capsule would separate from the habitat module and re-enter the Earth's atmosphere, while the habitat module would remain in orbit as a potential space station. The mission would have several scientific and technological benefits, such as advancing our understanding of Io and its unique geology, testing the human endurance and performance in deep space, and demonstrating the feasibility of using expandable modules and gravity assists for future exploration.